My Bluetooth just disconnected. Sorry about that. I was in the process of explaining the last portion of the guided practice, number 7. So when we look at this, the drawing's a little weird. This was what the book had. This point should be lower than this one, but it's not. So essentially what we need to do is determine if these two slopes of side J and H, so side J and H is going to be, so the slope of J and H is congruent to the slope of FG, and then we need to determine if the slope of JF is going to be congruent to the slope of HG. So what we're going to do is find the slope of JH. So the slope of JH is going to equal, well, what's the slope formula first of all? The slope formula, I know many of you, we've gone over this over the last semester and this semester as well. The slope formula is y2 minus y1 over x2 minus x1. So that means for JH, we're going to take J's coordinate, which is negative 7, 1, and H's coordinate, which is negative 3, 0. And we're just going to plug it in. We're going to take 1, because that's y2 minus 0. So we take one of the y's, subtract the other. Then we take the x, and then subtract the other x. So since we started with 1, that's going to be our y2. So our x2 is negative 7. And we're going to subtract negative 3. So that's going to be 1 over negative 7 plus 3, which is going to be 1 over negative 4. So the slope is going to be negative 1/4 for JH. So let's see if that matches the slope of, or is congruent to the slope of FG. So the point for F is going to be negative 5, 3, and the point for G is at negative 1 and 2. So then we're going to use the slope formula. We're going to take 3 and subtract the other y, which is 2. We're going to take negative 5 and subtract negative 1. So 3 minus 2 is 1. Negative 5 plus 1 is going to be negative 1/4. So it looks like these slopes are congruent. So we can say that these slopes are congruent. However, now we have to determine if if JF is congruent to the slope of HG. So we're going to look again to see if the slope of JF is congruent to the slope of HG. So JF, we're going to do the same thing. We have a coordinate at negative 7, 1 for J, and then for F, we have a slope at negative 5, 3, and then we have, basically we're going to plug that into the slope formula. We're going to have 3 minus 1 over negative 5 minus a negative 7. That's going to be 2. Negative 5 plus 7 is going to be 2, so that's going to give us 1. So if the slope of HG is equal to 1, we know that this quadrilateral is a parallelogram. So point H is going to be at negative 3, 0. And then point G is going to be at negative 1 and 2. So essentially what we're going to do is we are going to take 2, subtract 0, and we're going to take negative 1 and subtract negative 3. So that's going to give us 2 over negative 1 plus 3. So that's going to give us 2 over 2, which is 1. So since these two slopes of JF and HG are basically congruent. That means that these points basically create a parallelogram. So even though the drawing on the book doesn't look like it's a parallelogram, I think they just did it to throw you off and for you to use algebra. So since the opposite sides of the quadrilateral have congruent slopes, yes, this is a parallelogram. So this quadrilateral is a parallelogram. All right, so that concludes our guided practice, and I am going to now start the independent practice. If my mic cuts off, I'm sorry. It's going to stop the recording, and I'm going to have to create a new video. I don't know why my headphones, they just don't, they aren't compatible, I guess, with the Windows, so it keeps like unrecognizing my USB for my headphones, and it's causing some issues I got to look into. But anyways, let's look at the independent practice. So I am pulling up the independent practice right now for lesson 2. And we are going to start it. All right, so number 9, it says determine whether each quadrilateral is a parallelogram. So this is very similar to what we are doing in the guided practice and also what we did in lesson 1. So it wants to know if this is a parallelogram. We have discussed the property that a parallelogram has opposite angles that are congruent. If we look at 120, is that congruent to the opposite angle of 130? No. So since 120 degrees is not equal to, since it doesn't equal 130 degrees, that means that these opposite angles are not congruent. And basically, this quadrilateral is not a parallelogram. No. This quadrilateral is not a parallelogram. And that's because, again, the opposite angles are not congruent. So number 10, it's the same type of problem. We have a parallelogram, and I will get into the theorem. There's a theorem on page 813 that talks about if the opposite sides of the parallelogram are parallel and congruent, then the quadrilateral is a parallelogram. So since you have these congruent sides, because they both equal 10, and then this arrow, remember, shows that these two sides of this quadrilateral are parallel. Because they're congruent in length measurement, they're both 10, and they have parallel symbols. This is a parallelogram. So yes, this quadrilateral is a parallelogram. Okay, so now I'm going to do number 15 and 16. Actually, since 15 and 16 are the same, type of problem, I am going to just do number 15 because I really want you to practice finding the slope of the sides of a quadrilateral to determine if it is a parallelogram. So I just did this. This was problem 7 in the guided practice. But basically, your homework will have you do number 16 and 17, which will give you more practice. So they give you point Q or vertex Q at -2 or -1, 2. R is at 4 and 3. S is at 2 and -1. And then T is at -2, -1. So I'm going to graph this real quick. So Q is at -1 and 2. And then R is at 4 and 3. And then S is at 2 and -1. And then T is at -2, -1. So it looks like this. And just by the look at the graph, it doesn't look like it, but looks can be deceiving. So we're going to use the slope formula for determining the different slopes of the sides to see if they are the same. And if they are the same, that means that they are parallel. So we have at Q, we have -1, 2. At T, we have -2, -1. R is at 4 and 3. And S is at 2 and -1. So we're going to find QR, that slope. And we want to see if it's congruent again to the slope of the opposite side, TS or ST. So QR, the slope formula again is y2 minus y1 over x2 minus x1. And point Q is going to be at -1, 2. And then R is at 4 and 3. So we're just going to plug it in where we're going to go 3 minus 2. Since I started with 3, that means that R is going to be your x2, y2. So we're going to go 4 minus -1. 3 minus 2 is 1. 4 plus 1 is 5. So that means that QR slope is 1/5. We're going to see if it's the same as the slope of ST. So S is going to be at 2, -1, and point T is going to be at -2, -1. And we're going to just plug it into the slope formula. We're going to have -1 minus -1 over 2 minus a -2. So -1 plus 1 is going to be 0. And we are going to have 2 plus 2, which is 4. So 0 divided by 4 is 0. A slope, it can be equal to 0. It just means it's a straight line. And if we look, I'm just going to show you that QR slope and ST slope are not the same. So since the opposite sides of this parallelogram do not have the same slope, it means that this quadrilateral is not a parallelogram. So we don't have to find the slope of the other sides. If it's determined that the two opposite sides are not parallel or do not have the same slope, you can immediately stop and not have to do the other two sides. But if they are the same, like in problem 7, then we would have to find the other side's slope. So for QT and SR. Sorry, the mic just went off again. So fortunately, my recording did not stop. So again, no, this quadrilateral is not a parallelogram. All right, so this concludes lesson 2. You're going to have maybe 4 problems to do for homework. Definitely check out this video, and I will be posting lesson 3 on tomorrow. Have a great day. Thank you so much, and I will see you in class at 9 o'clock for those that are in the Monday, Wednesday cohort. For the Tuesday, Thursday cohort, I will see you on Thursday. Have a great day.